Alright guys, now we've completed our setup. From here on, let's continue to get to know the system a bit more closely, guys. I mean, we've learned the general architecture. Yes, we've started to understand some things, but let's go a bit further. What does the producer do? What does the consumer do? What's the relationship between them? What's going on inside? Let's keep learning a bit more about all that, guys. Now, as a publisher, when you want to send information, how is the information you send actually transmitted and understood, guys? You send a topic. In other words, you send a topic to the server. You say, this is my key, this is my value, and you send it like that. After you send this, some processes happen inside. The thing you send gets serialized first, guys. This serialization process uses Apache's own templates. Guys, you need to send it in accordance with these templates. By default, the template is like this. It's usually in the form of a string and an object. But if you want, you can manage this and switch it to a different template mode. First of all, the data you send gets serialized. Guys, after it's serialized, if it needs to be split into partitions, it's sent for partitioning. For example, there's a topic. Let's say this topic will be processed in 2 parts. In that case, it's sent in 2 parts. Of course, these are sent to the broker. After these steps, the broker writes them to its own disk. It puts them in a certain order. If there's no timestamp, it adds its own timestamp and continues. Now, you need to pay attention to this here. Guys, did the Kafka broker manage to write the data you sent, or was it able to read it during a read operation? You have a lot of such things to consider. You need to configure these. For example, think of it like this. I made a sales transaction. In the sales transaction, I said, I've completed my sale. Let the others do their part. For example, the information that the sales transaction has been completed will be sent to the user via email and SMS. Now, there need to be 2 separate services to handle this. Let one be the mail center service and the other be the SMS service. Now, both of these microservices are listening to the topic sent by our purchasing service. Let's say as soon as the topic is published, the other side tried to read it or tried to, but couldn't manage. In other words, the reading process didn't happen. Why? Because there was something on the server, or something related to itself, so it couldn't complete this process. There was a problem. What will happen then? Here, inside the relevant broker and related to that topic, there is a retry mechanism. What does this do? It tries again. Guys, so you can retry the operations done here. For example, I tried to do something, it didn't work, it gave an error. Then try again, try one more time. Let's say, how many times did you set this to? Try 5 times. If it still can't be done after the 5th try, then throw an exception. So, the mechanism here actually works exactly like this, guys. But there are some situations here, friends. Okay, I sent it to Kafka so that an operation can be performed. These will be written. But what if there was a problem while I was doing this operation? If there was an issue with the brokers and one of the brokers crashed? Or if there were problems while I was writing or reading? And how are we going to solve these? Let's say there was a problem with the reading process. Right when I was about to read, one of the brokers crashed. There's a problem. What happens in a situation like this? Now, in these kinds of situations, the topic that was sent, in other words, the action or event sent by the procedure absolutely needs to be delivered to the other side. For example, there's such a requirement. It absolutely must be delivered and processed. Maybe it needs to be retried multiple times. How are we going to decide on these and how will we choose them? Actually, here you can see the different structures of the acknowledge part. guys. So, I'm sending a request. Or rather, let's put it this way. I'm creating a topic. Whether this topic is received by the other side or not doesn't really matter to me, for example. Because I've done my part, I've published it. By saying this is the other side's problem, if there's an error or an issue, I've left the mechanism of retrying or checking it up to them. Usually, the structure works like this. So, you perform an action. The other services that will be affected by the result of this action listen to your topic and process it from there. So actually, once the job leaves the publishing producer, it's not really cared about that much. Why? Because their concern is this. I've done my job, I've informed you. Whether you do it or not is up to you. That's why, in this part, the ones who need to pay attention are not the publishers, but the listeners. In other words, the consumer side. There are different mechanisms on the consume side here, friends. Here, we see a bit more about the guarantee mechanisms related to the producer's writing and reading, the usage patterns. You can actually see concepts here like how the topic we've sent is written to other brokers, or when we request to read, if there's a problem within these brokers, it's fetched from there and returned to the user. Let's break this down a bit more, guys. Let's get into the details of the matter. Let's say, as you can see here, you have 4 events, guys. These 4 events have been sent within the system and processed. Now, the other side needs to receive them. So how does that work? The other side we're talking about is the consumer side. So, the producer sent the event, and the consumer will receive it. So, the one listening to this, in other words, the one who will process it, has made the sale, and I will send an SMS to the user about this sale. Now, whether I can send my SMS or not, what do I need to do? Actually, I need to check, guys. For example, there was an error in the system at that moment. That is, there is an error in the SMS system. For example, you ran out of credits or the SMS sending system, my service provider, returned an error. So what happens in such a situation? For instance, you read the data from the queue and what does the user have there? There's a phone number for which a sale has been made. You took the phone number and sent it. But the system is broken. The SMS didn't go through, but the data you read from the queue is lost. Because you already read it, the queue thought, well, this user, I mean the consumer, took it. Since it was taken, the process is considered complete. It either deleted it from the queue or marked it as read in the queue. So what happened? The data is lost, folks. In other words, you couldn't send the SMS to the user. So, there's something important to pay attention to here. Here, at most once, let's say, process at most one time. The logic here is this. When a record is added to the queue and someone reads it, the queue considers the process done. Well, that's not really ideal. That's not good for us. So, the second scenario, because if there's a problem, poof, it's gone from the queue. Use at least once. What does that mean? Now, you read this from the queue. There was a problem. You'll try again. If there's a problem, you'll try again. This makes a bit more sense. And finally, in the third scenario, it's the part where we're sure the operations here are done. So these won't be deleted from the queue. But when they're read, when the operation is actually performed, they'll be marked as processed. The most commonly used one among these is the second, at least once. That's the part we use most often. But of course, this is entirely up to you, guys. You don't have to do it this way. You might say, for example, our system isn't like that. Like, how should I put it? It's not a system that causes problems. Whenever it's received, it gets processed, or it could also work like this. In these kinds of systems, you need to pay attention to this. Normally, people tend to imagine a microservice as if it's running on a single server. But it doesn't have to be that way. For example, let's say I have a microservice. My SMS microservice. I'm sending so many SMS messages that it's not really possible for a single microservice to handle all that load. So, for example, I scale up the same microservice on Kubernetes. In other words, I create its replicas. On Kubernetes, for instance, you can create 50 instances of a microservice. So, I have 50 SMS microservices. Now, here's the question. In this module structure you see here, which option should I choose to do the right thing? Just think about it, 50 microservices. All 50 of them are listening to the same queue. In other words, they're all listening to the same topic. So, when a new message arrives on that topic, which one will process it? What happens if all 50 of them process it at once? The same user would get 50 messages. So, what needs to happen then? It means that for this value in the topic, it's enough if just one of those 50 servers, that is, just one of the SMS servers, processes it. There's a very important point to pay attention to here. When one of them reads from the queue, the others shouldn't process it. The others need to be able to tell that one of them has read it. But if the one that read it can't complete the process and fails, that topic still needs to remain in the queue. So it can be retried. Yes, these are the parts that need to be solved, folks. I mean, at first glance it might seem very logical, but these are things that will be worked out as they're tried and processed within a project. So, it makes a lot of sense to choose the one that best fits your needs and move forward with that, folks.